Hey everybody, this is Mrs. Breezer, and I am going to explain to you how to use trigonometry to solve for missing sides of a right triangle. But first I'm going to do a little review with you. If you remember when we were working, we had the abbreviation of SOHCAHTOA, so we'll have to really use these when we're setting them up today. Alright, so sine, you always put the angle next to it. And if you remember, you can use like the acute angle here or here, but you will never use that right angle. So whatever angle, I'm just going to use C this time, and that will go right next to the word sine, cosine, or tangent, the angle measure. And on the other side will be whatever two sides you're using, and we already talked about that and you've been practicing that that's opposite over hypotenuse. Okay, so and then the cosine is adjacent over hypotenuse. So the cosine, again, we'll base it on C, is adjacent over hypotenuse. So from this angle C, the adjacent side is right here, and of course hypotenuse is opposite your right angle. Then the tangent of the angle, again we'll just talk about C this time, is opposite over adjacent. So again, from this angle C here, the side or the leg opposite would be here, and then we would use adjacent leg, which would be BC. Alright, so now the order that you're going to be using, of course, you'll always have the word sine, cosine, or tangent first, sitting right next to your angle measure, equals whatever two sides you happen to be using. But that's not the order that you're going to think about it in. The first thing you're going to do is pick whatever angle you're working with, and then you're going to pick whatever two sides you're working with according to that angle, if they're opposite, adjacent, or hypotenuse, whichever two they are. And once you know those two, then you're going to pick sine, cosine, or tangent, and so that's the third thing you do. Okay, so now we're going to use that to solve for x, solve one of the sides. Notice we are given an angle, 56. We're given one side length of 13 and one side length of x that we're looking for. So the first thing that we have to do here is, like I said in the previous step, we need to decide which angle we're going to use. So obviously the 56 is what we want. So I'm going to write down the 56-degree angle. We'll come back in a moment and figure out what to put before the sine, cosine, or tangent. That's our last thing. Then we pick the two sides. So the two sides, we're going to use the x, because that's what we're looking for, and we're going to use the 13, because that's the one we know. Well, according to the 56-degree angle here, the x is opposite that, and the 13 is adjacent. We're not using the hypotenuse. So if you think about our SOHCAHTOA, the only one of those that uses opposite and adjacent together is T for tangent. So we then know that tangent is the one we're going to use, and tangent has to be opposite over adjacent in that order. So from the 56, x is opposite, that goes up top, and 13 is adjacent, so that goes down below. And now we're just going to solve this. If you remember from solving here, we need to get x alone. X is on the right side of our equation, and it's divided by 13. So what I want to do is show that we're going to multiply both sides by 13. I don't know if I can show this here. Times 13, that's supposed to say, and times 13 over here. I'm actually going to bring that down where it says 13 tangent 56 degrees equals x, because the 13's cancel out. Now what you see here is what you will actually punch into your calculator. So I have my scientific calculator here. I'm going to enter the number 13. I'm going to push the tangent button, and I'm going to push 56 in parentheses, I'm going to look and make sure it says degrees, which it does, and equals. And I'm going to round to the nearest tenth, so mine says 19.27 and it goes on. So rounded to the nearest tenth would be 19.3 equals x. And if you look at the length of it, that would make sense. It seems reasonable in comparison. The 13 is smaller, so that this is 19.3. And also keep in mind whenever you're using that hypotenuse that always has to be the longest, so that's kind of a way you can check your work as you go. Okay, I'm going to use there's another way of solving, not a different way of solving, but sometimes the way it's set up with where x is at, you have to solve slightly differently. So that's what this example will show. So again, the first thing I'm going to do is think about which angle measure I'm working with. So that, of course, is 32, since that's the one they gave us. Okay, from there we're going to look at the two sides. The two sides are the x and the 11 here. Okay, here's the x and here's the 11. So from the 32, we're using opposite and we're using adjacent again. So again, we're going to use tangent. So the tangent of 30 degrees, and it has to be in the order opposite over adjacent. So it's going to be 11 over x. Now if you look at this, you'll notice that the x is on the bottom this time. So we're not going to just multiply both sides by x. You could, and then divide at the end. But instead what we're going to do, another way of solving this, is to turn this into a proportion. And then we can simply do cross product. So we're going to take 1 times 11, and we're going to take the tangent of 32 times x. A nice way to do that so that you don't mess up later is when you're taking the x times the 32 this way, is put the x out front. So it's showing that we're going to take x times the tangent of 32 will equal the other cross product of 1 times 11, which is 11. Okay, now you can see that in order to get x alone, we have to divide both sides by tangent of 32 degrees. Tangent and 32 are actually connected. This is like one number right here, so you have to work with them together. So we're going to divide by the tangent of 32, divide by the tangent of 32. These cancel. So this time when I entered in my calculator, I'm going to push 11 divided by tangent of 32 in parentheses, and I get 17.6. Now the same thing would happen if you were using sine or cosine. The only difference is you would be using the hypotenuse and then either the opposite side or the adjacent side. So that is how you find one of the missing sides, when you know one angle and one side, and of course it has to be the right triangle, but you can never use the right angle. It always has to be one of the acute angles. Good luck.